In this video, we are looking at how to find the magnitude or the length of a vector. And here, if I'm given an arrow starting from x subscript 1 to y subscript 1, and the terminal point is x subscript 2, y subscript 2, then this is the formula I'm going to use. And see, this is the distance formula you have encountered before in geometry. And if it's in component form, this is the formula to use. So let's look at an example. So here we are given a vector v represented by pq, and we are given the p is equal to that point, q is equal to that point. So we are going to find the magnitude of v. So this is going to be given by x2, which is 2, minus x1, negative 3, so squared, and then I'm going to add y2, which is 7, minus 5 squared, and then I'm going to get the square root of that. So what do I get? This is going to be 5 squared, and this is going to be 2 squared, which is going to be the same as square root of 29. So square root of 29, and I could square root of 29, if I put this in the calculator, is about 5.39. So that is the length, so about that. So that's the length of that vector, or the magnitude. So let's do an example when the vector is given in component form. To find the magnitude, as a formula, it's going to be given by the formula, the second formula we see right here. And this formula says that we do square root of a squared, so the a is 3, plus b squared, so b is 4, which is equals to 9 plus 16, square root of that, which is equals to 5. So that is the length of that vector. Here we are looking at how to find the direction Argo of a vector. A simple way to specify the direction of a vector is to state its direction. Remember, we say the vector has two things. It has direction and it has magnitude. We already know how to find the magnitude. And now we are looking at how to state the direction of the vector. And we use an Argo to do this. So, and its direction, theta, the Argo that v makes with the positive x-axis. So what do we mean? If this is my vector, v, so this is the Argo we are talking about. Remember, sometimes the vector could even be here, and this is the Argo theta we'll be looking for. So that's how to, so that's the direction Argo, or it could be in this quadrant. This is the Argo we are looking for. This is theta. Remember, it says the Argo, it makes with the positive x-axis. So the Argo, it makes with this axis. So here, find the direction Argo of a vector v, and it's given in component form. And here we are told the vector is 6, 8. So that means this direction here is 6, and here it's going to be 8, because that point here is 6, 8. So now we need to get this Argo right here. And to get this Argo, you can see that the Argo made here, see there's a 90-degree Argo right there. So I'm going to use SOHCAHTOA to find Argo theta. And if I'm right here where the Argo is, I can see this is opposite. The 8 is the opposite, and this is adjacent. So the Argo I'm looking for, I can use tan So tan theta is equals to 8 over 6. So theta is equals to tan inverse 8 over 6, which is equals to, so this angle is going to be equal to 53.1 degrees. So that is the direction angle. So if you're describing the angle, the direction of the vector, you can use that angle. So here we have another example, and this time the angle is in, I have to see what quadrant the angle is, and I see this is going to be in quadrant 3. So I'm looking for the angle made with the positive x-axis. So that's the angle I'm going to be looking for. So that is theta. But note that I cannot be able to use this triangle here to find theta. But I can get that angle here. So this is 3, negative 3. This is a negative 4 right there. So I'm going to use 10 and figure out the reference angle. And I'm using that symbol, remember, like we did with the reference angle, to show that reference angle or that acute angle. So I'm going to say 10. So tan theta. Let me go back here, and I'm going to say, I'm going to write here tan of theta is equals to opposite negative 4 over negative 3. So that means this angle, the reference angle, is going to be given by tan 4/3, which is going to equal to, which is equals to 53.1. Note that it is the same angle because I have the same points, just in reduced form. But the angle I actually need is the obtuse angle. So how do I get that angle? I'm going to take 180 degrees, and then I'm going to add 53.1, and that is going to give me 233.1 degrees. So that's going to be the angle. So that's how to find the direction angle of a vector. Here we are looking at how to resolve a vector, and that means looking for the horizontal and vertical components of a vector given the direction angle and the magnitude. And example 1, we're going to sketch it here. So if I have a vector with a direction angle of 120, so if that is 120 degrees, that's the direction angle. This is the vector right there. And I need to find the horizontal and vertical components. So this vector is in quadrant 2. So to find the vertical component, which I'm going to call V subscript, the horizontal, I'll call it V subscript X, meaning its distance along the X-axis. And this is V Y, meaning it is the vertical component of vector V. So I need to know this angle right here. And to get V of X, I'm already given the hypotenuse, which is 6. So what I'm going to write here, I'm going to write cosine of 60 degrees is equals to adjacent over hypotenuse, which is 6. So that means the horizontal component is equals to 6 cosine of 60. I put that in the calculator, and that will give me 3. I'm going to find the horizontal, so the vertical component. So I'm going to use sine of 60 is equals to v of y, which is the opposite, over 6. So to get v of y, it's just going to be 6 sine of 60. I put that in the calculator, and I get about 5.2. And then all I need to know is that to write this, since I did not use 120 degrees, I used the reference Argo. I just need to know that in the v of x is in second quadrant. So Vx, so the components of this vector are going to be, the x component is 3, but it's actually -3 since it's in the second quadrant, and the vertical component is just going to be 5.2. So those are the components of that vector. So let's do another one here. So just note that this one shows positive because I didn't use 120 degrees. I used the reference Argo here, which is 60 degrees, because I'm using this triangle. So I had to make sure it's negative because I can see this is negative x-axis, but the height is still on the positive y-axis. So those are the components. So we do another example, and for this example, let's sketch it. So this one has a direction Argo of 15, so it's in quadrant 1. So the Argo is right there. So I make a triangle, 90 degrees, and here this is going to be Vx, Vy, and maybe a summary I can use to get the components. All I need to do is to use the magnitude. If I have a vector v, to get the horizontal component, I just need the magnitude of v and then cosine of theta, whatever theta is. And to get the vertical component, I just need to have the magnitude times sine of theta. So that's a formula I can use every time. I just have to know in which quadrant the components are so that I know when to make them positive and when to make them negative. So to get the components, this one is going to be, I know the magnitude is 18. So 18 cosine of 15. And the next one is going to be, the magnitude is 18 sine of 15 degrees. And I just need to put those values in the calculator. When I put these values in the calculator, I get to one decimal place, I get 17.4. And for the vertical component, I get 4.7. So that's the answer.